For a long time, astronomers believed the outer solar system was quiet and mostly empty. Beyond Neptune, there should only be scattered icy objects slowly orbiting the Sun in random directions. But recently, scientists began noticing something unusual. Several distant objects far beyond Neptune appear to move in strangely similar orbits, almost as if something massive is influencing them from deep space. At first, researchers thought it might be a coincidence, but the more they studied these distant worlds, the stranger the pattern became. Something in the outer solar system may be shaping their motion, and whatever it is, it might be hiding far beyond the known planets. Tonight, we explore one of the most intriguing mysteries in modern astronomy, the strange discovery beyond Neptune. The region beyond Neptune. For most of human history, the solar system seemed simple. The Sun sat at the center, surrounded by a small family of planets orbiting quietly through space. Mercury, Venus, Earth, Mars, then the giant worlds like Jupiter and Saturn, followed by the distant ice giants Uranus and Neptune. For a long time, Neptune was believed to mark the outer boundary of the solar system. Beyond it, astronomers once imagined there was almost nothing, just a vast region of empty space slowly fading into the darkness between the stars. But modern discoveries have revealed that this distant region is far more complex than anyone expected. Beyond Neptune lies a massive zone known as the Kuiper Belt. This region contains thousands, possibly millions, of icy objects, left over from the early formation of the solar system more than 4.5 billion years ago. Some of these objects are small chunks of rock and ice, only a few kilometers across. Others are large enough to be classified as dwarf planets. Pluto, once considered the 9th planet, is actually one of the largest members of this distant population. But Pluto is not alone. Scientists have discovered several other dwarf planets in this region, including Eris, Haumea, and Makemake. These frozen worlds orbit the Sun at enormous distances where sunlight is extremely weak. At such distances, temperatures can drop below -220 degrees Celsius, making the outer solar system one of the coldest places in our cosmic neighborhood. For many years, astronomers believed the Kuiper Belt was simply a chaotic field of icy debris. Objects that were expected to move in random orbits, slowly drifting through space without any clear pattern. But as telescopes improved and more distant objects were discovered, something unusual began to appear. Some of these objects did not seem to move randomly at all. Instead, a small group of extremely distant bodies appeared to follow strangely similar orbital paths. Their orbits stretched far beyond Neptune and pointed in roughly the same direction through space. At first, scientists thought this might just be a coincidence. But the more objects astronomers discovered, the more the pattern began to stand out. And that pattern suggested something surprising. Something massive might be influencing the motion of these distant worlds. Something hidden, far beyond Neptune. The strange pattern. As astronomers continued studying objects beyond Neptune, they began collecting more precise data about their orbits. Each time a new distant object was discovered, scientists carefully calculated its path around the Sun. These calculations revealed how far the object traveled, how long its orbit lasted, and the direction it moved through space. At first, everything seemed normal. Most objects in the Kuiper belt followed random orbits, just as scientists expected. Some traveled in nearly circular paths, while others followed elongated routes that carried them far from the sun before looping back again. But a small group of extremely distant objects behaved differently. Their orbits were unusually stretched, reaching hundreds of astronomical units away from the sun. Even more surprising was the direction of these orbits. Instead of pointing randomly across the solar system, several of them seemed to be aligned. Imagine drawing several long, oval-shaped paths around the sun. Instead of being scattered in every direction, these paths were tilted and oriented in nearly the same way. This kind of alignment should not exist. Over millions of years, gravitational interactions with planets, especially Neptune, should slowly scatter these objects into different directions. But the pattern remained. The more astronomers studied the data, the clearer it became that something unusual might be happening in the outer solar system. One of the most famous examples of these strange objects is a distant world known as Sedna. Sedna travels on an extremely long and stretched orbit around the Sun. At its closest point, it is still much farther away than Pluto. At its farthest point, it travels nearly 1,000 astronomical units from the Sun. That means Sedna takes more than 11,000 years to complete a single orbit. But Sedna was not alone. Other objects with similar distant orbits were discovered later, and many of them shared a strange feature. Their orbits seemed to point in similar directions. At first, scientists wondered if this was simply a coincidence. After all, the number of known objects in this distant region was still relatively small. But as more discoveries were made, the pattern kept appearing again and again. The odds of this happening randomly were extremely low. Something might be shaping these orbits. Something massive enough to influence objects hundreds of billions of kilometers away. And whatever it was, it appeared to be hiding somewhere beyond Neptune. A hidden planet? As the strange alignment of distant objects became clearer, astronomers began asking an important question. What could possibly be influencing objects so far from the Sun? At those enormous distances, the gravitational pull of the known planets becomes very weak. Neptune, the outermost major planet, still affects nearby objects in the Kuiper belt, but its influence fades the farther you go. Yet the distant objects scientists were studying were extremely far away. Too far for Neptune alone to explain their unusual orbits. This led researchers to consider a bold possibility. Perhaps there is another planet in our solar system, a large world far beyond Neptune that has not yet been discovered. Astronomers began exploring this idea through computer simulations. They created digital models of the solar system and tested different scenarios to see what might produce the strange orbital patterns they observed. When they added an unseen planet to the simulations, something remarkable happened. The distant objects began to behave exactly like the real ones. Their orbits aligned in similar directions, just as astronomers had observed in the outer solar system. According to these models, the hidden planet would need to be quite massive, possibly 5 to 10 times the mass of Earth. This would make it a type of planet astronomers call a super-Earth. If such a planet exists, it would likely be a cold and distant world, orbiting the Sun hundreds of astronomical units away. At those distances, sunlight would be extremely faint. The planet would move very slowly through space, taking thousands, or even tens of thousands, of years to complete a single orbit around the Sun. Because it is so distant and dim, detecting it with telescopes would be incredibly difficult. But its gravity could still reveal its presence. By slowly pulling on nearby objects over millions of years, the planet could shape the strange orbital patterns astronomers have discovered. This mysterious world has been given a name. Scientists call it Planet 9. For now, Planet 9 remains only a hypothesis. No telescope has directly observed it. But the unusual behavior of distant objects beyond Neptune continues to suggest that something large may be hiding in the outer darkness of our solar system. The Planet 9 hypothesis by the mid-2010s. The strange pattern in the outer solar system had become difficult for astronomers to ignore. More and more distant objects were being discovered, and several of them seemed to follow similar orbital orientations. These objects were not part of the main Kuiper Belt population. Instead, they belonged to a smaller and more mysterious group known as Extreme Trans-Neptunian Objects, or ETNOs. These worlds travel on enormous, elongated orbits that stretch far beyond Neptune. Some of them reach hundreds of astronomical units from the Sun before slowly returning inward again. What puzzled astronomers most was not just how far these objects traveled. It was the way their orbits were arranged. Instead of pointing randomly in different directions, many of these distant objects seemed to share a similar orientation in space. Their elongated paths were clustered together. This type of alignment should slowly disappear over time. Gravitational interactions with the giant planets, especially Neptune, should gradually scatter these objects into random directions. Over millions of years, the pattern should break apart. But that was not what scientists were seeing. Instead, the alignment appeared to be stable. Something seemed to be maintaining the pattern, and whatever was causing it had to be extremely massive. This is when two astronomers from the California Institute of Technology began studying the problem more closely. Their names were Konstantin Batygin and Michael Brown. Michael Brown was already well known in the astronomical community. Years earlier, he had been part of the team that discovered the dwarf planet Eris, an object so large it forced scientists to rethink Pluto's classification. Now, Brown and Batygin were looking at the outer solar system in a completely new way. Instead of focusing on individual objects, they examined the overall structure of the distant region beyond Neptune. They gathered data on the most distant known objects and analyzed the orientation of their orbits. The results were striking. Several of the objects appeared to cluster in the same region of orbital space. The probability of this happening by chance seemed extremely small. To investigate further, Batygin and Brown turned to computer simulations. Using powerful models of the solar system, they began testing different scenarios. First, they simulated the outer solar system without any additional planets. In this model, the distant objects quickly lost their alignment. Their orbits scattered randomly, exactly as traditional theories predicted. But then, the researchers tried something different. They added a massive unseen planet into the simulation. The results were remarkable. With the extra planet included, the distant objects began to behave exactly like the real ones astronomers were observing. Their orbits remained aligned. Some objects even developed the same extreme orbital angles that had puzzled scientists for years. It was as if the hidden planet's gravity was quietly organizing the distant region of the solar system. Instead of drifting randomly, the distant objects were being guided by a powerful gravitational influence. According to the calculations, this hidden world would need to be 5 to 10 times more massive than Earth. That would make it significantly larger than our planet, but still smaller than the ice giants Uranus and Neptune. Astronomers refer to this type of planet as a super-Earth. Interestingly, super-Earths appear to be very common in planetary systems around other stars. Many exoplanet systems discovered by telescopes contain planets several times the mass of Earth. Yet, our own solar system seemed to lack such a planet. Planet 9 could change that. If it exists, it would fill a surprising gap in our planetary family. But the planet would also have to be extremely distant. Battigan and Brown's models suggested that Planet 9 might orbit the Sun at an average distance of about 400 to 800 astronomical units. For comparison, Pluto orbits at an average distance of only about 39 astronomical units. This means Planet 9 could be more than 10 times farther from the Sun than Pluto. At such enormous distances, sunlight becomes extremely faint. The amount of light reaching the planet would be hundreds of times weaker than what Pluto receives. As a result, the planet would be incredibly dim when viewed from Earth. Even the most powerful telescopes might struggle to detect it. The planet's orbit would also be highly unusual. Instead of traveling in a nearly circular path like most planets, Planet 9 would likely follow a very elongated orbit. At its closest approach to the Sun, it might still be hundreds of astronomical units away. At its farthest point, it could travel more than 1,000 astronomical units into deep space. One complete orbit around the Sun might take 10,000 to 20,000 years. That means, since the time humans first began building civilizations on Earth, Planet 9 would have barely moved along its orbit. This extremely slow motion is one reason why the planet has not yet been discovered. Astronomers usually detect planets by observing how they move against the background stars. But a planet this distant would move very slowly, almost imperceptibly over short periods of time. To a telescope, it might appear almost like a stationary star. Another factor making the search difficult is the sheer size of the sky. Even though astronomers have narrowed down possible regions where Planet 9 might exist, the search area still covers thousands of square degrees. That region contains millions of faint stars and distant galaxies. Finding a dim, moving planet among them is a tremendous challenge. Yet, the Planet 9 hypothesis has continued to gain attention within the scientific community. Several independent studies have examined the orbital patterns of distant objects and found evidence supporting the possibility of a hidden planet. Some researchers have also suggested that Planet 9 could explain another mystery. A small number of distant objects in the outer solar system have highly tilted orbits. Instead of orbiting roughly in the same plane as the planets, these objects move at steep angles. Some even travel in nearly perpendicular directions relative to the rest of the solar system. Computer simulations show that the gravitational influence of a distant massive planet could gradually create these tilted orbits. Over millions of years, repeated gravitational interactions could push objects into extreme angles. This added another piece of evidence supporting the Planet 9 idea. But the hypothesis is not without its critics. Some astronomers believe the observed alignment might still be explained by observational bias, because telescopes often search specific areas of the sky. The objects discovered may naturally appear clustered. Others suggest that the combined gravity of many small objects in the outer solar system could produce similar effects. For now, the existence of Planet 9 remains uncertain, but the mystery itself has sparked one of the most exciting searches in modern astronomy. Observatories around the world are scanning the sky in hopes of detecting this hidden world. New telescopes, such as the Vera C. Rubin Observatory, are expected to dramatically improve our ability to detect faint, slow-moving objects. If Planet 9 exists within the predicted region, these new surveys may eventually reveal it. And if that happens, the discovery would transform our understanding of the solar system. A ninth planet would once again join our cosmic neighborhood. A massive world that has been silently orbiting the sun for billions of years, hidden in the distant darkness far beyond Neptune. Why haven't we seen Planet 9? If Planet 9 truly exists, a natural question immediately follows. Why hasn't anyone seen it yet? After all, astronomers today have incredibly powerful telescopes. These instruments can observe galaxies billions of light years away, detect planets orbiting distant stars, and even capture detailed images of objects near the edge of the observable universe. So how could a planet inside our own solar system remain hidden? The answer lies in three key factors: distance, brightness, and motion. First, distance. Planet 9 is believed to orbit extremely far from the Sun. According to current models, the planet could travel hundreds of astronomical units away from our star. 1 astronomical unit is the distance between the Earth and the Sun. Neptune orbits at about 30 astronomical units, and Pluto at around 39 astronomical units. Planet 9, however, could orbit at distances between 400 and 800 astronomical units. That means the planet could be more than 10 times farther away than Pluto. At those enormous distances, sunlight becomes extremely weak. The brightness of sunlight decreases rapidly as distance increases. In fact, it follows what scientists call the inverse square law. This means that if an object moves 10 times farther away from the sun, it receives 100 times less sunlight. If it moves 20 times farther away, it receives 400 times less sunlight. So a planet hundreds of astronomical units away would be incredibly dark. Even if Planet 9 were large, the amount of light it reflects toward Earth would be extremely small. To telescopes on Earth, it might appear as nothing more than a tiny faint dot among countless distant stars. The second challenge is brightness. Objects in the solar system are usually detected because they reflect sunlight. The brighter the object, the easier it is for astronomers to see. But Planet 9 would reflect almost no light. Because of its distance from the sun, the planet would be illuminated only by very faint sunlight. From Earth, its brightness could be hundreds of times dimmer than Pluto. Detecting something that faint requires extremely sensitive telescopes and long exposure times. Even then, it could easily be overlooked among the millions of faint objects in deep space images. The third challenge is motion. Planets are usually identified by observing how they move across the sky relative to background stars. Nearby planets move noticeably over short periods of time. Even distant objects like Pluto slowly shift position over weeks or months. But Planet 9 would move much more slowly. Because its orbit may take 10,000 to 20,000 years, the planet would travel only a tiny fraction of its path each year. In telescope images taken days or even months apart, it might barely appear to move at all. To detect such slow motion, astronomers must carefully compare images taken over long periods of time. This process requires enormous amounts of data and careful analysis. And even then, a faint object moving slowly across a crowded star field could easily be missed. Another complication is the size of the search area. The sky is incredibly vast. Even though astronomers have calculated possible regions where Planet 9 might be located, these regions still cover huge sections of the sky. Each of these areas contains millions of stars and galaxies. Searching through this immense field for a faint, moving planet is like trying to find a single grain of sand on an entire beach. But despite these challenges, astronomers are actively searching for Planet 9. Several observatories around the world are scanning the sky for faint, moving objects that might match the predicted orbit. One of the most powerful telescopes involved in the search is the Subaru telescope in Hawaii. This telescope has an extremely wide camera, capable of capturing large areas of the sky while still detecting faint objects. Astronomers have used Subaru to survey many of the regions where Planet 9 might be hiding. So far, the planet has not been found. But each search helps narrow down the possible locations. Another major development is the construction of the Vera C. Rubin Observatory in Chile. This telescope will conduct one of the most ambitious sky surveys ever attempted. Once it begins full operations, the observatory will repeatedly photograph the entire southern sky every few nights. Over 10 years, it will collect an enormous time-lapse map of the universe. This kind of continuous observation is exactly what astronomers need to detect extremely slow-moving objects like Planet 9. If the planet exists within the observable range of the Rubin Observatory, scientists believe it could eventually appear as a faint dot slowly drifting across the sky. The observatory is also expected to discover thousands of new objects in the outer solar system. Many of these could be additional extreme trans-Neptunian objects, providing more clues about the structure of the distant solar system. Another strategy astronomers are using is analyzing old telescope images. Over the past several decades, telescopes around the world have captured millions of deep space images. It is possible that Planet 9 has already been photographed, but simply not recognized. Because the planet moves so slowly, it might have appeared as a faint stationary dot in older images. Scientists are now re-examining these archives using improved computer algorithms. By comparing images taken years apart, They hope to detect subtle motion that might reveal the hidden planet. In astronomy, this kind of rediscovery has happened before. Objects sometimes remain unnoticed in data for years before someone recognizes their significance. Planet 9 could be hiding in plain sight, but there is also the possibility that the planet is even farther away than predicted. If it is currently near the farthest point in its orbit, it could be so dim that even the most powerful telescopes struggle to detect it. In that case, finding it could take many years. Still, astronomers remain optimistic. History has shown that gravitational clues often lead to real discoveries. The planet Neptune, for example, was discovered in 1846 after astronomers noticed strange movements in the orbit of Uranus. Using mathematical calculations, they predicted the location of an unseen planet. When telescopes were pointed toward the predicted region of the sky, Neptune was found almost exactly where scientists expected it to be. Planet 9 could represent a similar moment in modern astronomy, a world discovered first through mathematics and gravitational evidence, and only later through direct observation. For now, the mystery continues. Somewhere in the vast darkness beyond Neptune, a distant planet may still be orbiting the Sun, too faint to see, too slow to easily detect, but not completely beyond our reach. And with new telescopes scanning the skies, the discovery of Planet 9 may simply be a matter of time. Could it be something else? Even though the Planet 9 hypothesis is exciting, many astronomers remain cautious. In science, extraordinary ideas must always be tested carefully. Just because a theory seems to explain certain observations does not automatically mean it is correct. Researchers must consider other possible explanations and examine every piece of evidence. Some scientists believe the strange orbital patterns beyond Neptune might not require a hidden planet at all. Instead, they suggest that the pattern could be caused by observational bias. Observational bias happens when the way we collect data influences the results we see. Most telescopes do not scan the entire sky evenly. Astronomers often search specific regions where conditions are favorable for detecting faint objects. If many discoveries happen in the same part of the sky, the objects found there may naturally appear clustered. This clustering could give the illusion that the objects share similar orbital orientations, even if the overall population is actually random. In other words, the strange alignment might simply be the result of where astronomers are looking, rather than the influence of a hidden planet. To test this idea, scientists have tried simulating how telescopes search the sky. These simulations examine whether a random distribution of distant objects could appear aligned due to the limited regions where observations take place. Some studies suggest that observational bias could indeed produce patterns similar to those currently observed. However, other researchers argue that the clustering still seems too strong to be explained by bias alone. The debate continues. Another possibility involves the combined gravitational influence of many smaller objects in the outer solar system. The Kuiper Belt is not empty. It contains thousands of icy bodies, and there may be millions more that are too small or distant to detect. If enough mass exists in this region, the combined gravitational pull of these objects might slowly shape the orbits of nearby bodies. Over millions of years, Their collective influence could potentially produce patterns in orbital alignment. But calculations suggest that the Kuiper belt probably does not contain enough total mass to produce the strong gravitational effects seen in the simulations. Still, the idea remains under investigation. A third possibility involves events from the early history of the solar system. Billions of years ago, the solar system was a chaotic environment. The giant planets were likely moving through the protoplanetary disk, scattering smaller bodies across enormous distances. Some astronomers think that during this early period, gravitational interactions could have pushed objects into the strange orbits we observe today. These ancient events might have left behind a fossilized pattern that still exists in the outer solar system. If that is the case, the strange alignment may not be caused by anything currently influencing those objects. Instead, it could be a relic of the solar system's violent past. Another idea suggests that a passing star may have disturbed the outer solar system long ago. Our Sun formed within a dense cluster of young stars. During the early stages of its life, other stars may have passed relatively close to the solar system. A passing star's gravity could have pulled distant objects into unusual orbits. Even a brief gravitational interaction might have reshaped the distant structure of the solar system permanently. Some models show that such an encounter could produce orbital patterns somewhat similar to those observed today. But determining whether such an event actually occurred is extremely difficult. Yet another hypothesis proposes something even more exotic. Some researchers have suggested that a primordial black hole might exist in the outer solar system. Primordial black holes are hypothetical objects that may have formed shortly after the Big Bang. Unlike black holes formed from collapsing stars, these objects could be much smaller. If a primordial black hole were captured by the Sun's gravity billions of years ago, it might now orbit far beyond Neptune. Because black holes emit no light, such an object would be completely invisible to telescopes. Its presence would only be detectable through its gravitational influence. In theory, a small black hole could potentially produce effects similar to those attributed to Planet 9. However, this idea is considered extremely speculative. There is currently no evidence that such an object exists in our solar system. Still, exploring unusual possibilities helps scientists test their assumptions and strengthen their understanding. In astronomy, many surprising discoveries have come from investigating ideas that once seemed unlikely. Another key factor in solving the mystery is discovering more distant objects. The more extreme trans-Neptunian objects astronomers find, the clearer the overall pattern will become. If future discoveries continue to show strong orbital alignment, the case for Planet 9 will grow stronger. But if new objects appear randomly distributed, the alignment may simply disappear as the sample size increases. In other words, the mystery may resolve itself as more data becomes available. This is why ongoing sky surveys are so important. Large-scale observation programs are currently scanning huge areas of the sky for faint objects beyond Neptune. Each new discovery adds another piece to the puzzle. Some astronomers believe that within the next decade, we may discover hundreds of additional distant objects. These discoveries will help scientists determine whether the strange alignment is real or simply a statistical illusion. For now, the evidence remains intriguing but incomplete. The outer solar system is still one of the least explored regions of our cosmic neighborhood. Many of its distant worlds remain unknown, and somewhere in that vast darkness, a hidden planet might still be waiting to be found. Or perhaps the true explanation will turn out to be something even stranger than Planet 9 itself. A solar system we still don't fully understand. For centuries, humanity believed the solar system was a well-understood place. By the early 20th century, astronomers thought they had already discovered nearly everything important about our planetary neighborhood. The Sun sat at the center, surrounded by 8 planets, along with a few asteroids and comets. But the deeper scientists began to explore space, the more they realized how incomplete that picture was. The discovery of the Kuiper Belt completely changed our understanding of the outer solar system. Instead of an empty region beyond Neptune, astronomers found an enormous population of icy worlds. Some of them were small fragments left over from the formation of the solar system. Others were large enough to become dwarf planets like Pluto and Eris. Yet the Kuiper Belt may only be the beginning. Far beyond this region lies another mysterious structure called the Oort cloud. The Oort cloud is believed to be a vast spherical shell of icy bodies surrounding the solar system, at distances thousands of times farther away than Neptune. It may extend nearly halfway to the nearest stars. Scientists think this distant cloud contains billions, possibly trillions of frozen objects. These objects are thought to be the source of many long-period comets that occasionally travel toward the inner solar system. But the Oort cloud remains mostly theoretical. No telescope has ever directly observed it. The objects within it are simply too small and too far away to detect easily. Even today, much of our understanding of the Oort cloud comes from mathematical models rather than direct observation. This means that the outer solar system may still hold many secrets. Planet 9, if it exists, would be part of this mysterious region. Its orbit might lie between the Kuiper Belt and the inner edge of the Oort cloud. A planet in this distant location could have profound effects on the structure of the solar system. Over millions of years, its gravity could reshape the orbits of nearby objects, scattering some inward toward the Sun and pushing others outward into deep space. Some scientists even believe that Planet 9 could help explain certain unusual comets. A few comets observed entering the inner solar system follow unexpected trajectories. Their paths do not always match the patterns predicted by standard models of comet origins. If a massive distant planet exists, it could occasionally perturb objects in the outer solar system, sending them on long journeys toward the Sun. This kind of gravitational influence would slowly reshape the outer regions of the solar system over time. Another mystery that Planet 9 might help explain involves the tilt of the solar system. The Sun itself is slightly tilted relative to the orbital plane of the planets. This tilt is small, only about 6 degrees, but it has puzzled astronomers for decades. Some models suggest that a distant massive planet could slowly influence the overall orientation of the planetary system. Over billions of years, the gravitational pull of Planet 9 might have gradually tilted the orbits of the planets relative to the Sun's rotation. If this idea is correct, the hidden planet may have been shaping our solar system for billions of years without anyone realizing it. But Planet 9 may not be the only possibility. Some researchers think the outer solar system might contain multiple undiscovered objects. Instead of one large planet, there could be several smaller planets or dwarf planets influencing the distant region. These objects might work together to create the patterns astronomers observe. Another intriguing idea is that our solar system once contained more planets than it does today. During the chaotic early stages of planetary formation, gravitational interactions between giant planets could have ejected one or more planets into interstellar space. Some models suggest that a fifth giant planet may once have existed between Saturn and Uranus before being thrown out of the solar system entirely. If something similar happened in the outer regions, a distant planet might have been pushed onto a very elongated orbit far beyond Neptune. Such an event could explain why Planet 9's orbit appears so unusual compared to the other planets. Even today, the solar system continues to surprise us. In recent decades, astronomers have discovered dozens of dwarf planets, thousands of Kuiper Belt objects, and entirely new classes of distant celestial bodies. Each discovery reminds us that our cosmic neighborhood is far more complex than we once imagined. The outer solar system is not just a quiet, frozen wasteland. It is a dynamic and evolving region filled with mysterious worlds. And somewhere in that vast darkness, far beyond Neptune, a hidden planet may still be orbiting silently around the Sun. A planet that could reshape our understanding of the solar system once again. The ongoing search, if Planet 9 truly exists, then somewhere in the dark outer reaches of the solar system, a massive world is quietly orbiting the Sun. But finding it is one of the greatest challenges modern astronomy faces. Unlike planets closer to the Sun, a distant planet would not shine brightly in telescope images. It would only reflect a very small amount of sunlight, making it extremely faint. And because of its enormous orbit, it would move across the sky very slowly. To astronomers searching for it, Planet 9 would appear as nothing more than a tiny moving dot among millions of stars. The search for such an object requires patience, powerful telescopes, and a lot of careful data analysis. One of the most important tools in this search has been the Subaru telescope, located on the summit of Mauna Kea in Hawaii. The Subaru telescope has a special instrument called the Hyper-Supreme Cam, which allows astronomers to capture wide images of the sky while still detecting extremely faint objects. With this powerful camera, scientists can scan large regions of the sky where Planet 9 might be hiding. Astronomers take images of the same region multiple times over several nights or weeks. Then, they compare the images carefully. Most of the dots in the images are distant stars or galaxies that remain fixed in place. But an object inside the solar system will move slightly relative to the background stars. Even a slow-moving planet can be detected this way if astronomers look closely enough. So far, these searches have discovered many new objects in the outer solar system. Some of them are new members of the Kuiper Belt. Others belong to the more distant population of extreme trans-Neptunian objects. Each new discovery helps scientists refine their models of how the outer solar system is structured. In addition to telescopes scanning the sky today, astronomers are also looking at old astronomical data. Over the past several decades, telescopes around the world have captured countless images of the night sky. It is possible that Planet 9 has already been photographed many times without anyone realizing it. Because the planet moves so slowly, it might have been mistaken for a distant star. By comparing old images with modern ones, scientists hope to detect subtle movement that might reveal the hidden planet. Computers now play a crucial role in this process. Modern algorithms can scan through massive datasets containing millions of objects. These programs search for tiny changes in position that human observers might miss. Artificial intelligence and machine learning tools are also being developed to help identify unusual objects in astronomical images. But the biggest breakthrough in the search for Planet 9 may come from a new observatory currently being prepared in Chile. The Vera C. Rubin Observatory is expected to transform how astronomers study the sky. Once it begins full operations, the observatory will conduct a massive survey called the Legacy Survey of Space and Time. Over the course of 10 years, the Rubin Observatory will repeatedly photograph the entire southern sky. Every few nights, it will capture new images of billions of stars and galaxies. This continuous monitoring will create a kind of cosmic time-lapse movie of the sky. Objects that move slowly across the sky, like asteroids, comets, and possibly Planet 9, will become much easier to detect. Many astronomers believe that if Planet 9 exists within the predicted distance range, the Rubin Observatory could eventually reveal it. Even if the hidden planet is not found, the survey will likely discover thousands of new objects in the outer solar system. These discoveries will provide valuable clues about the structure and evolution of our planetary system. Some of those objects may even turn out to be entirely new types of celestial bodies. Astronomy has a long history of unexpected discoveries. When Uranus was discovered in 1781, it doubled the known size of the solar system overnight. When Neptune was discovered in 1846, it confirmed that gravitational calculations could predict unseen worlds. More recently, the discovery of the Kuiper Belt revealed that the outer solar system is far more crowded than scientists once believed. Planet 9 could represent the next major step in that story. If it exists, it would become one of the most important planetary discoveries in modern history. But even if it turns out that no such planet exists, the search itself is still incredibly valuable. Every new object discovered in the outer solar system helps scientists build a clearer picture of how our planetary system formed billions of years ago. And with each new discovery, we are reminded that the solar system is still full of mysteries waiting to be explored. If Planet 9 is real, if Planet 9 truly exists, it would dramatically change our understanding of the solar system. For decades, we have believed that the solar system contains 8 major planets. Mercury, Venus, Earth, and Mars form the rocky inner worlds, while Jupiter and Saturn dominate the middle region with their enormous size. Farther out, Uranus and Neptune orbit as icy giants at the edge of the planetary system. Beyond them lies a distant region filled with dwarf planets, comets, and icy debris. But the discovery of a ninth planet would mean that our solar system is larger and more complex than we once thought. According to current predictions, Planet 9 would be unlike any planet we have seen nearby. Scientists believe it might be 5 to 10 times the mass of Earth, placing it in a category called a super-Earth. Interestingly, planets of this size are extremely common around other stars, yet our own solar system seems to lack one. If Planet 9 exists, it could fill that missing category. The planet would likely be a cold, distant world made mostly of ice and rock. Because it would orbit far beyond Neptune, sunlight reaching the planet would be extremely weak. The surface temperature could be hundreds of degrees below freezing. Instead of a bright blue sky like Earth, the sky on Planet 9 would appear almost black, with the sun shining as nothing more than a small, distant star. From that distance, the sun would look no brighter than some of the brightest stars we see from Earth. A year on Planet 9 would also be incredibly long. While Earth takes 365 days to orbit the Sun, Planet 9 might take 10,000 to 20,000 years to complete a single orbit. That means, if the planet exists, it has completed only a few hundred orbits, since the solar system formed more than 4.5 billion years ago. Another fascinating question is how Planet 9 formed. There are several possible explanations. One idea suggests that the planet formed closer to the Sun, along with the other planets. During the chaotic early stages of the solar system, gravitational interactions between the giant planets could have pushed Planet 9 outward. Eventually, it may have been thrown into a distant, elongated orbit where it remains today. Another possibility is that Planet 9 originally formed around another star. During the Sun's early life inside a cluster of young stars, close encounters between stars may have occurred. In such an encounter, the Sun could have captured a wandering planet from another planetary system. If that happened, Planet 9 would technically be an alien planet, born around a different star before becoming part of our solar system. A third possibility is that Planet 9 formed directly in the outer solar system from a disk of icy material. However, many astronomers think this is less likely. At such great distances from the Sun, there may not have been enough material to build a planet of that size. Regardless of how it formed, the discovery of Planet 9 would raise many new questions. Scientists would want to understand its composition, its atmosphere, and how it interacts with the rest of the solar system. It could even help explain certain mysteries about distant comets and the structure of the Kuiper Belt. But perhaps the most exciting part of the discovery would be what it reveals about the limits of our knowledge. Even after centuries of studying the sky, it is possible that a massive planet has been hiding in our own cosmic neighborhood. A world orbiting the Sun so far away that we have only begun to suspect its existence. If Planet 9 is eventually discovered, it will remind us that the solar system is still full of secrets, and that even in our own backyard of space, there may still be entire worlds waiting to be found. The future of the mystery. Today, the idea of a hidden planet beyond Neptune remains one of the most fascinating mysteries in astronomy. Some scientists are convinced that the strange patterns observed in the outer solar system strongly suggest the presence of an unseen world. Others remain skeptical, arguing that the evidence is still incomplete. But one thing is certain: the search for answers has only just begun. Over the next decade, new telescopes and powerful sky surveys will explore the outer solar system in ways that were never possible before. The most important of these projects is the Vera C. Rubin Observatory, currently preparing to begin full scientific operations in Chile. Once active, this telescope will conduct one of the most detailed surveys of the night sky ever attempted. Every few nights, it will photograph enormous portions of the sky with incredible sensitivity, capturing billions of stars, galaxies, and faint moving objects. Because it will repeatedly observe the same regions over many years, astronomers will be able to track objects that move extremely slowly across the sky. This type of long-term monitoring is exactly what is needed to detect a distant planet like Planet 9. Even if the planet is very faint and moves only slightly each year, the Rubin Observatory could eventually reveal its motion against the background stars. But even if Planet 9 itself is never discovered, these new surveys will still transform our understanding of the solar system. Astronomers expect to discover thousands of new objects beyond Neptune. Some of them may be dwarf planets. Others could belong to entirely new populations of distant bodies that scientists have not yet imagined. Each new discovery will help researchers better understand how the solar system formed and evolved billions of years ago. In many ways, the outer solar system is still one of the least explored regions of our cosmic neighborhood. Compared to the planets closer to the Sun, very few spacecraft have traveled there. Most of what we know comes from telescopes, observing faint points of light from millions or even billions of kilometers away. The vast darkness beyond Neptune remains largely unexplored, and it may contain many more surprises. Planet 9 may be out there, slowly orbiting the Sun in a distant path that takes thousands of years to complete. Or the strange patterns astronomers see may ultimately lead to a completely different explanation. Either way, the mystery has already opened a new chapter in the exploration of our solar system. A reminder that even after centuries of discovery, the universe still holds many secrets, and sometimes the greatest discoveries are not found by looking farther into the universe, but by looking more carefully at our own cosmic backyard. For centuries, humanity believed the solar system was a simple and well-known place. 8 planets orbit the Sun, followed by a distant region of icy debris beyond Neptune. But recent discoveries suggest that our cosmic neighborhood may still hold hidden surprises. The strange orbits of distant objects beyond Neptune have raised a powerful question. Is there something massive influencing them from the darkness of the outer solar system? Some scientists believe the answer could be Planet 9, a distant super-Earth slowly orbiting the Sun thousands of astronomical units away. Others argue that the mystery may have a different explanation, perhaps observational bias, ancient gravitational events, or structures we do not yet fully understand. For now, the truth remains unknown. But one thing is certain: the outer solar system is far more mysterious than we once imagined, and somewhere in that vast darkness beyond Neptune, a hidden world may still be waiting to be discovered. the edge of the solar system. When we imagine the solar system, most of us picture the familiar planets. Mercury racing close to the Sun. Earth, our home. The giant worlds Jupiter and Saturn. And finally, the distant ice giants Uranus and Neptune. For a long time, this was the complete map of our planetary system. But as our telescopes improved and our understanding of space expanded, scientists realized that the solar system does not simply end at Neptune. Instead, Neptune marks the beginning of a vast and mysterious frontier. Beyond it lies an enormous region filled with icy objects, frozen worlds, and distant debris left over from the birth of the solar system more than 4.5 billion years ago. The first clue that something existed beyond Neptune came with the discovery of Pluto in 1930. At the time, Pluto was believed to be the 9th planet. But decades later, astronomers began discovering more objects similar to Pluto, orbiting far from the Sun in the same distant region. These discoveries revealed that Pluto was not unique at all. Instead, it was simply one of many icy bodies living in a huge structure now known as the Kuiper Belt. The Kuiper Belt stretches from about 30 astronomical units to more than 50 astronomical units from the Sun. Inside this region are thousands of known objects and likely millions more that are still too small or distant to detect. These worlds are made mostly of rock and ice. Some are only a few kilometers across, while others are large enough to be classified as dwarf planets. But the Kuiper Belt may only be the inner boundary of something much larger. Farther out, the solar system fades gradually into deeper and darker regions. One of the most mysterious of these regions is believed to be the Oort cloud. The Oort cloud is thought to surround the solar system in a vast spherical shell that may extend tens of thousands of astronomical units into space. If it exists as predicted, it could contain trillions of icy objects left over from the earliest days of planetary formation. These objects are so distant and faint that no telescope has ever directly observed them. Yet, astronomers believe the Oort cloud is real because it provides a logical explanation for long-period comets. These comets sometimes appear suddenly in the inner solar system on extremely long orbits. Their trajectories suggest they originate from a distant reservoir far beyond the known planets. The Oort cloud could be that reservoir. Between the Kuiper Belt and the Oort cloud lies an enormous region that is still poorly understood. It is within this distant zone that the idea of Planet 9 begins to make sense. If a massive planet exists far beyond Neptune, it could be orbiting somewhere in this dark frontier. Its gravity could be quietly shaping the distant solar system, influencing the orbits of objects hundreds of astronomical units away. But the outer solar system may hold even more surprises. Recent observations have revealed strange objects that do not fit neatly into existing models. Some distant worlds follow extremely elongated orbits that carry them far beyond the Kuiper Belt. Others travel on highly tilted paths that do not match the flat orbital plane of most planets. These unusual objects suggest that the outer solar system is far more dynamic than scientists once believed. Gravitational interactions between distant bodies may still be reshaping the region even today. Another fascinating possibility is that the solar system could contain additional undiscovered dwarf planets. Objects like Pluto, Eris, Sedna, and Makemake represent only the largest known members of the distant population. There may be dozens more similar worlds waiting to be found. Some astronomers believe that a body even larger than Pluto could still be hiding somewhere in the outer darkness. Detecting such objects is extremely difficult. At these enormous distances, even large worlds reflect very little sunlight. To our telescopes, they appear as faint moving dots that can easily be mistaken for distant stars or galaxies. Yet the search continues. Every year, new surveys discover additional objects beyond Neptune. Each discovery helps scientists refine their understanding of how the solar system formed billions of years ago. Many astronomers now believe that the early solar system was far more chaotic than we once imagined. During its first few 100 million years, giant planets may have migrated through the protoplanetary disk, scattering smaller bodies across enormous distances. Some of these objects may have been pushed into the Kuiper Belt. Others may have been thrown outward to form the Oort cloud. A few may even have been ejected from the solar system entirely, becoming rogue planets wandering through interstellar space. If Planet 9 exists, it might be a survivor of this chaotic past. Perhaps it formed closer to the Sun and was later thrown outward by gravitational interactions with the giant planets. Or perhaps it was captured from another star system when the Sun was still part of a dense cluster of young stars. Either way, its presence would tell us something important about the early history of our solar system. But even without Planet 9, the outer solar system remains one of the most exciting areas of modern astronomy. It is a region where new discoveries are still happening regularly. And each discovery reminds us that the solar system is far larger and more complex than the simple model we once imagined. The Sun's gravitational influence extends far into the darkness, shaping the motion of countless unseen worlds. Beyond the planets, we know lies an enormous frontier filled with icy bodies, distant comets, and possibly hidden planets. A frontier that we are only beginning to explore. And somewhere out there, beyond Neptune and beyond Pluto, the solar system slowly fades into the endless darkness of interstellar space, a boundary not marked by a sharp edge, but by a gradual transition from our local cosmic neighborhood into the vast galaxy beyond. It is a reminder that even the place we call home in the universe is still full of mysteries waiting to be discovered. The mystery that changed our view of the solar system. For most of human history, the solar system seemed simple. The Sun stood at the center, surrounded by a small family of planets moving in quiet and predictable orbits. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune formed the outer boundary of what we believed to be our cosmic neighborhood. Beyond Neptune, scientists once imagined there was very little left to discover. Just a cold, dark region filled with scattered debris and a few distant comets. But over the past few decades, that picture has changed dramatically. The discovery of the Kuiper Belt revealed that the outer solar system is filled with thousands of icy worlds. Pluto, once considered the 9th planet, turned out to be just one member of a vast population of distant objects orbiting far beyond Neptune. Then, astronomers began discovering even stranger bodies, objects like Sedna, whose orbit stretches incredibly far from the Sun, extreme trans-Neptunian objects that travel along elongated paths, reaching hundreds of astronomical units into deep space. And most intriguing of all, some of these distant objects appeared to follow strangely similar orbital patterns. Instead of pointing randomly across space, their orbits seemed clustered in a way that scientists could not easily explain. This unexpected pattern led astronomers to consider a bold possibility. What if something massive was influencing these distant worlds? Something hidden far beyond the known planets. This idea eventually became known as the Planet 9 hypothesis. According to current models, Planet 9 could be a super-Earth, a world perhaps 5 to 10 times more massive than our own planet. It might orbit the Sun at distances hundreds of times greater than the distance between Earth and the Sun. A year on such a planet could last tens of thousands of years. From that distant location, the Sun would appear only as a bright star in an almost completely dark sky. If Planet 9 exists, it would represent one of the most significant discoveries in modern astronomy, but finding it is incredibly difficult. At those enormous distances, the planet would reflect very little sunlight. Even powerful telescopes might only see it as a faint dot moving slowly across the sky. And because its orbit is so large, the planet could be hiding almost anywhere within a huge region of space. The search for Planet 9 continues. Astronomers around the world are scanning the skies with advanced telescopes, analyzing vast amounts of data, and searching for faint, moving objects that might reveal the planet's presence. New observatories, like the Vera C. Rubin Observatory, will soon survey the sky in greater detail than ever before. These powerful instruments may finally provide the data needed to confirm whether Planet 9 truly exists. But even if the mysterious planet is never found, the search itself has already changed how we view the solar system. It has revealed that the outer regions of our planetary system are far more complex than scientists once believed. Beyond Neptune lies an enormous frontier of icy worlds, distant comets, and unexplored structures that stretch far into the darkness between the stars. The solar system does not simply end at the orbit of the last known planet. Instead, it fades gradually into deeper and more mysterious regions. Regions where hidden worlds may still exist. Regions where the sun's gravitational influence slowly gives way to the vast emptiness of interstellar space. And, perhaps most importantly, this mystery reminds us of something fundamental about science. Even in our own cosmic backyard, there are still discoveries waiting to be made. We have explored the moon, sent spacecraft to the outer planets, and built telescopes capable of observing galaxies billions of light years away. Yet a massive planet could still be hiding somewhere within our own solar system. If Planet 9 is eventually discovered, it will be a powerful reminder that the universe is still full of surprises. And if it turns out that no such planet exists, the strange patterns in the outer solar system will still push scientists to develop new ideas about how planetary systems evolve. Either way, the mystery beyond Neptune has already opened a new chapter in our exploration of space. A chapter that reminds us how little we truly know about the distant reaches of our own planetary system. Somewhere beyond Pluto, beyond the Kuiper Belt, and far into the cold darkness of the outer solar system, something strange may still be waiting to be found.